Good evening, everyone. Thank you very much for joining us. My name is Shane Murphy. I'm Technical Director at Ashgrove. I'm joined this evening by my colleague, Mike Dennehy, standing here beside me. He's going to keep an eye on your questions. And you'll see at the bottom of your screen there in a second, I'll show you where to type your questions into. So we'll try and answer them as we go, unless maybe they're not relevant at the particular time we receive them, but in which case we'll either answer them at the relevant point or we'll keep them until the end. So again, thanks for joining. What will we expect from this evening? So solar PV today, as most of you know, is relatively, I'm going to say, non-technical, and that might be fine for guys like us in the building here who are energy geeks. But for somebody who's facing into it for the first time, maybe as a homeowner or something like that, obviously it's a big decision. So, but we'll go through, I suppose, the ins and outs of it. How does it work? What affects us in terms of the design considerations? Where do we start? We'll talk a little bit about the electricity connections and what do you need to do in order to get agreement from the grid to connect in, and so on. We'll talk about the grants. There was talk of a reduction there before Christmas, but they actually paused it. So we would expect that reduction might kick in on the 1st of January next, but we don't know that for sure. But that is certainly what was originally agreed. We'll talk about tips and tricks of I suppose when you're facing into this, and I suppose if we were in your shoes, what would we do? So we would, as with any of these talks are, I suppose, we try to keep them non-technical, and more importantly, I suppose, that this isn't about Ashgrove or how fantastic we are. You don't care, so I won't waste my time telling you. But these are very factual talks, as they always are, whether it's, we're doing talks on vacant and derelict houses or commercial solar or whatever it is, heat pumps. It's facts and figures, and maybe our opinions here and there where they might be useful to you. But other than that, we're not going to be giving you sales talk, as they say. So the questions and answers button there on the bottom of your screen. So if you have there will be professionals on the call here who are looking for CPD points, so let us know who you are and we will sort that out for you. Other than that, if you have any questions, just type them in there and we will answer, as I say, as we go, or if not, we will get back to your questions at the end. So a tiny bit about Ashgrove, I won't bore you. We're around since 2001. We're renewable specialists since then. More recently, back day one, I suppose we were heat pumps, solar, I'm going to say ventilation, and then more recently, insulation, windows, doors, etc. So more home upgrades than maybe energy like we were at the start. Today we're an SEI registered one-stop shop, a community energy grant contractor and a Better Energy Homes contractor. We won't be talking about that really. Other than to know that we did in 2024, that's an old figure now, we need to put up the 25 figure. We did about 17% of the one-stop shop and CEG projects in the country in 2024, if we exclude the housing bodies, the approved housing bodies. That's really, it sounds like we're blowing there. I suppose the important point for you is that we know how these grants work. We have the highest pass rate in the country as well. We're very good at paperwork and making sure that the quality of our installs is up to the expected standards, etc. Excuse me. Today there's 82 people in our office. It's actually higher now. And I suppose it's important that all calls are answered. There are more and more group housing scheme projects popping up, people contacting us where they have 20 or whether they have 80 or 200 houses in the scheme, and they want solar proposals or solar agreements. And there will obviously be, when you have 20 or 100 houses, there will be discounts, because once we're inside in the estate and we're moving from house to house, it's easier and cheaper for us to carry out projects like that. And we do a lot of free information webinars like you see here, over 100 a year, and they're intended obviously to be available to everybody, and hopefully, as you see at the end of it, we're obviously a company who needs to sell stuff, but that we're not selling on these webinars. We have an app, which is probably not too important for today's topic. It's called whatgrant.ie, but it explains in short videos the pros and cons of the various grants. Upcoming seminars, vacant and derelict one is the next big one is in Mullingar on the 16th of March. Again, we'd expect big numbers at that, probably north of 700 or 800 people. So if anybody is looking at vacant or derelict house grants, the next big seminar. So into the topic. So solar panels, how do they work? I suppose we don't really need to go into what's happening within the panel here, right? We just for our typical homeowner, we just need to know that electricity comes out the end here, right? And it comes out in the shape of direct current. So that's not alternating current. That's the same as a battery for your car or battery, AAA battery or whatever. It's direct current. In that state, it's unusable in your house. It needs to be alternating current. And how we make that usable is we send it through a thing called an inverter. And that inverter then converts it from direct current to alternating current. And the amount of these that we might use, we'll come to it maybe in greater detail later on. Obviously, the more solar panels I have, the more power I'm going to get. And if I had a factory, obviously, and I was using 1,000,000 kilowatt hours versus 10,000 kilowatt hours, obviously I would choose a larger number of panels. We won't be maybe going into, we certainly won't be going into designing big arrays like that this evening. It's not important. Roof size as you use less power. So the sorry, there's something popping up on my screen here. Will you just do a sound check for me outside, please? I just moved the microphone there and I'm just making sure that it's okay. Would you check outside, please, Matt? Sorry, guys, about that. I just had a warning pop up on my screen. So once the direct current passes through the inverter, it can go to a few different places. As is shown here, it's coming down here into what we call our consumer board. So that's into my fuse board, and it goes from there then to my fridge, my freezer, my lights, my heat pump, my television, or wherever I want. And if I have a day where I'm producing, I'm going to say 6 kilowatt on the roof, but my house is only using 2, well, I'm going to have a surplus at that point, and I'm going to have 4 that I'm going to put out onto the electricity grid, and I'm going to get credit for those, and that's calculated by this meter that we see here. And actually, just 1 second there. Apologies, guys. I'm just having a tech issue here. Just take that out and turn on the sound, Mike. Just take it out here and turn on the sound. How's that? So I'm just making sure, guys, that that's all okay. I might be overreacting now, but it's as well to be safe rather than sorry. So the seconds. So in the case where I have a surplus here, I end up exporting whatever I'm not using to the right here. And in the case where I have a deficit, so I have a scenario maybe where on a day like today where the sun wasn't as bright, where I'm only producing 2 kilowatt, and the house is consuming, call it 4 or 5. Well, in that case, I'm actually going to be importing whatever the shortfall is. Okay, so some people think it's an either-or scenario, that it switches over to the grid or it switches over to the solar. The two of them are running simultaneously, and it's uninterrupted if I'm in a surplus or a deficit scenario. So in the case where I have a battery, the battery actually sits on the DC side here. So we would use a battery in a scenario where I know I'm going to have a surplus of electricity. This is something that's always debated. We often hear from the geniuses down the pub that if you don't have a battery, you're wasting your time. That's not, in fact, true. In fact, it's rarely true. We would say about 1/3 of the projects that we see probably deserve a battery, and the other 2/3 probably shouldn't have a battery. They should run without. And again, when we do the calculations, we use software called Open Solar. What we do, we'll be looking at it maybe a little bit in a second. When we look at where you are in Ireland, I'm presuming you are in Ireland, where you are, what direction the house is facing, how many solar panels you have, and then we also tell the software roughly what your usage is. We can put in your monthly electricity usage, and then it tells us whether a battery will be useful or not. Essentially, if I don't have at the end of the day electricity left over from my solar panel, in other words, if I don't have a surplus, well, it won't go into the battery, and therefore I've paid for a battery that won't be paying for itself. So we would say in that case, don't put in a battery. So in very small systems, if you have a very small roof where you can only put up 8 or 10 panels, you probably shouldn't have a battery because you won't ever have surplus. If you have a very big roof and you want to put up a lot of solar panels and you're not there during the day, you're not using power during the day, well, you are going to have a surplus during the day, and therefore maybe you might include a battery. And then we start to feed in as well electric cars, all the rest of it. So it becomes a more complex question. So I hope, despite the fact I was thrown there a small bit with the sound, I hope I'm after covering that slide logically for you. So here is a picture maybe out of the piece of software. The solar panel in this case, as you can see here, is producing 5.5 kilowatt. That's what we call an instantaneous power figure. So that's kilowatts. And then as opposed to kilowatt hours, the inverter is deciding where that goes. In this case, the house is only consuming 0.3, and the rest of that is going through the meter out onto the grid. So I would be getting credit then for 5.1 kilowatts. And at the end, if that continued for an hour, I would have 5.1 kilowatt hours. So sometimes the solar industry mixes up kilowatts and kilowatt hours. We won't go spending much time at it, but I would just say it's the same as I was driving my car at 100 kilometers an hour. It's very different from I drove 100 kilometers. One is a rate and one is a distance or a quantity. So so that's how the inverter makes those decisions for us, what goes out onto the grid, etc. And the meter records what actually is being exported. The app really just looks pretty, and we can tell it to maybe change decisions if we're using batteries, etc. Okay. So for anybody we'd be talking to in the domestic house, the first thing we would ask, it's not to say we always get, is the load profile. So we would look at, okay, how much energy do you use over a 12-month period? In a domestic house, it might be whatever, 5,000, 6,000, 10,000 kilowatt hours. Okay. The next question is, okay, do you have an electric car? Okay, that because it's obviously we have to take that into consideration. Do I have a heat pump? If I have a heat pump, it's likely that a lot of my electricity will be used in winter. Do I use the tumble dryer a lot? And so on. So the first thing we want to figure out is your 12-month profile. So in this case, you can see here that in January, February, and March, it's high, it starts to drop. And then in October, November, December, it increases again. So there's no real surprise in this. Lights will be on more. There's a chance that the tumble dryer will be on more. Maybe there is or isn't potentially a heat pump in the equation here. But clearly, you can see, and it should be intuitive, that solar should be more productive in the sunnier months than it would be in the less sunny months. That was something we were battling a few years ago, maybe go back 3 or 4 years. You had salespeople saying, it doesn't really need sun, it just needs daylight. Clearly untrue, and I think most people don't need to be told that today. They have some friend who has solar panels, and very clearly, if I get direct sunlight, it's more productive than on a dull day. But yeah, a few years ago, we were having to explain ourselves there, believe it or not. And then the next thing, after understanding the 12-month period, we like to understand the 24-hour profile. And it's simple enough for a house. It's one of two things. It's either what we call a single peak profile, which you see there on the left, right, where maybe I'm working from home. You can see the little blue line here. I get up in the morning and I shower and whatever, and I'm working away. So I have a kind of a relatively constant use all day until evening. And then you can see the solar panels start to wake up at 8 or 9 o'clock, and then during the day they peak. Anything between under the yellow line and above the blue line would be considered surplus, and that will either be exported or it will go into a battery. But in a case like this, where I have a double peak, I have a peak of usage in the morning and I have a peak of usage in the evening. But during the day, when the sun is at its most intense, my solar panels are obviously producing, and all of that then between those two graphs would either be exported or put into batteries. So we would feed all of this into the software. Ultimately, I would say 9 times out of 10, our decision is very simple in the finish, regardless of what the software says. The roof is probably too small, and regardless of how many panels and batteries and all the rest of it, the system design is determined by the roof size. So, or maybe it mightn't be in this case. This house was in Limerick. We did a heat pump here maybe 10 years ago. The software actually here, as you can see, we would get the error code from the customer, in this case, Joe. And from Google Earth, we can pick out his house. We essentially tell it the height of the roof, the pitch of the roof, and maybe any other trees or anything around that might give shading. But what you can see here is that the yellow color here that you see on the front, I suppose, shows where the sun is at its most intense over the year. So you can see south facing is getting most of its energy here, very yellow. The back of the roof there is obviously not yellow, right? And then on the if you went with an east-west system here, which is on this bit sticking out, you can see that at the back of the chimney there's some shading. Now, what it does there is it'll take a statistical view of how many hours over how many days will that chimney cast a shadow on panels if they were behind it. And so, long story short, in a case like this, we would put panels on here in the software, and we would do a calculation. We would put panels on here on this side of the roof and do a calculation. Ultimately, what Joe decided to do was he didn't want them on his lovely house and he wanted them on his garage, and they went on the garage. But the software will churn out to us the number of kilowatts, as you can see here, megawatt hours per year. So it'll tell us within 1 or 2% accuracy how many kilowatt hours the system will produce, no matter where you put it on. So that's the I could click on that and it'll show you a movie, but I won't go into it now. But the software does all of that for us. And so that's that. I'm going to keep going. So, sorry, the other thing I wanted to say there is if we did decide to go behind the chimney there, we should know, or we should use what are called optimizers. An optimizer is where, if you can imagine, I'm going to describe it like radiators. If I had 10 radiators all piped together, so into the first one, out the other end, into the next one, out the far end, and I daisy chain them together, well, you can imagine if I turned down any one of the radiators, I'm turning off the other 9 at the same time, or at least I'm turning them down. The same thing happens with solar panels. If I have 6 of them in what we call a string, if any one of them is shaded, so it's no longer producing, I'm going to say 450 watt, it's only producing 200. Well, then the other 5 get pulled down to 200 as well, even though they're not in the shade. So we would, in that case, use a thing called an optimizer. We don't like using them. They're adding expense, and they're adding, I suppose, a long-term maintenance consideration that we ideally would not have, but we do in some cases use them. No, we often use them, but where necessary. That's where you might have heard that terminology, optimizer. Sorry, the one thing I didn't say back here a while ago actually was we talk about the 2 different types of inverters. I didn't mention it. You have a hybrid inverter. A hybrid inverter is the more complex one, which is if I was using a battery, I would use the hybrid. If I did not have a battery, I would use a string inverter. So it's the simpler form of an inverter, cheaper, of course, also. And I think about maybe 1/3 of the people we would have installing solar today, they mightn't put in a battery, but they would go with the more expensive inverter. And at least that then gives them the option of installing the battery down the line once they have some data. So after maybe 6 months or 12 months, they can see they're exporting electricity or they are not, and they can then make a real decision with useful data to say, actually, it makes financial sense for me to install a battery, or maybe I'm going to use my electric car to act as a battery for me, or whatever it is. So now I'm jumping around a bit. Apologies. So the electrical connection to the grid. So it's important to know when we put up, we're going to go on in a second to how we attach it to the roof and so on, right? But one of the important things, I suppose, if you're going installing solar is you are going to have a connection, obviously, to the electricity grid. Why they're interested in this is, I suppose, if you start producing electricity and if for any reason the power goes down outside your home, well, you're now producing 230 volt and you have a guy coming in to fix the power, and all of a sudden he's getting 230 volts coming out the wire against him. So they need to know that you're a micro generator. So we apply for that in the form of an NC6. It's a grid connection, so we just let them know that we're doing it. They can't actually stop us from doing it. Actually, at this size, at the bigger sizes, they can. If we go up to NC7, NC8, or NC5s, but for domestic, I'm just going to say that first one there is a very standard ask, and we fill out that NC6. Typically, your installer will do that on your behalf. Every now and then we see the installer doing his bit. He forgets about this bit. And what happens then is your electricity supplier now does not know that you're producing electricity. And therefore, at the end of the year, you'll be wondering why you're not getting credits. But they actually don't know you're connected. So the NC6 is important if you want to get your money back. Once you go up to the NC7, it's a bigger connection. Around 17 kilowatt. And the cost of that is for making that application is €977. If they turn you down, they'll give it back to you. But I suppose they want to stop everybody all over the country just applying for it. Just sure, why not? Because they saw that in the past with wind turbines, people started applying for connections that they were never going to use. So then the inverter size under the NC6, 5.5, strictly speaking, 5.75, but most of them are around 5.5 is your typical system, and that's the maximum amount you're allowed to put back onto the grid. Okay, you could actually have more up on your roof, but we need to restrict in that case then what you can put back onto the grid. It needs to be restricted to 5.5. So in this case, depending on the inverters, you can go, in this case, as it says here, 200% oversizing. So that means I can essentially put 11 kilowatts up on my roof, but all I can put back onto the grid is 5.5. Not every inverter there can take 200% oversizing. For example, if I had a 5.5 kilowatt inverter and I connected, I'm going to say 50 kilowatts onto it, the inverter can't deal with that. Okay, most of them are about 150%, 160%, but up to 200% is possible. So that's it. So what does 11 kilowatt look like? It's essentially 24 panels at 450 each. And again, the 450 watt there, we just have it inside in that calculation. It's a typical panel. You can get 470s, you can get 500s, you can get 570s, you can get 700s, whatever it is. It doesn't really matter, we would say, the size of the panel, the output of the panel. What's more important is that some people get bogged down in I want the 570s or I want the 700s. Sometimes in a smaller roof, you end up better off by using smaller panels and having more of them. Sometimes the bigger panels give you less flexibility, and you end up with more space, more dead space, we'll call it, where maybe I could have put, maybe if you can imagine, two smaller panels, one over the other on your roof. Whereas if I had one bigger panel, it would come down too far to allow me to put a second one below it, and so I end up with a whole pile of roof with no panels on it. So sometimes a smaller panel gives you more flexibility. Sounds less sexy, and people like bigger panels because his brother has one of them. But sometimes it's we just tell people don't get bogged down. The most important thing is that the total output is more important than the panel size. Clipping, we've put in clipping here on certain days. Clipping is a phenomenon where, if you can imagine that I have a license to export 5.5 kilowatts, but I'm producing 8 or 9 or 10, and I'm using nothing in the house. So the most I can export is 5.5. I'm producing, I'm going to say 10. I'm not using anything in the house. So I actually have to start turning my system down so that it only produces the 5.5. So essentially, I've wasted or clipped that 4.5 kilowatts. It's a very emotional one. It's unless you understand it, it's not easy to swallow, but it's nearly always the right thing to do. We really, really, really want to maximize, even on a dull day, if you can maximize that 5.5 kilowatts being exported, if that's what you're doing, clipping is the right thing. So you're oversizing on a really sunny day, you're having to waste some of that energy that's arriving, but statistically is still the right thing to do. So that's the terminology, clipping. Some of you might have heard of it and didn't understand it. And every now and then we get a person coming back afterwards. We always explain it, but it's an emotional one and people don't like it. Yeah, and the long story short there, all of the reports will tell us that you will produce and avail of more electricity over the year because of the oversizing. So the grants, a little bit about the grants. So 700 kilowatts, 700 euros per kilowatt for the first two, so that's 1,400. You'll get 200 euros per kilowatt for the next two, so that's another 400. So you're at 1,800 kilowatts there. That's the maximum as it currently stands for a domestic house. That was due to drop in January, but they held off on it. The reason for that was, again, it's another emotional one. My brother-in-law got 3,000 euro a few years ago or whatever it was, and now I'm only getting 1,800. The view is the grants are there, believe it or not to help you with your house. The grants are there to assist the industry to get up and running, where maybe 10 years ago wasn't there. And once it gets up and running, it gets more competitive. The price comes down, which it definitely has. And when it comes down, it is then feasible to reduce the grant. Okay. On any individual case, people find it hard to swallow, but this solar grant has worked. Solar panels are much cheaper today than they were 10 years ago. But of course, we'll still hear people moaning to us about it, and we understand it, but that's the reason for it. So if I had examples then on the grant, obviously simple maths, if I had 3 kilowatts, I have 7 panels and it's 1,600 euro of a grant. 6 kilowatts is 14 panels, it's 1,800. And no matter how many panels I put up after that, whether I put up another 2 or 22, I'm only getting 1,800 euro. So a little bit about the workings of it. I'm assuming now, by the way, that Mike is dealing with the questions. I'm seeing very few of them here. Mike, you will let me know if I need to deal with anything. I'll have a look at them there in a second maybe, but I think I'm covering them as I go. So the basic workings, if anybody is investigating solar panels, you'll have heard about the various bits and pieces. Fireman switch, maybe we'll start with. The fireman switch is what we're looking at here on the top left. It's, as the name suggests, it's there in the event that there's a fireman around the place. Again, it goes back to the scenario where, say there's a fire, the fireman comes in, he turns off the electricity outside outside at your gate or outside at the wall of your house. But unfortunately now the sun is shining and we're still producing direct current up here. And what the fireman switch does is once it recognizes that the power has gone off at the fuse board or at the isolator, it turns off the panels. They will still be live as far as here, but they won't be live on the far side of it. Obviously, you can't go around the house spraying water or swinging an axe in the knowledge that there's 230 volts somewhere. So that's what the fireman switch is for. It needs to be within, off the top of my head, I should know, but it's a while since I've done this presentation, but I think it's 1.5 meters of entry to the house here. Mike will actually know that if he wants to let me know. It has to be very close. As you can imagine, it can't be a live cable running down through the house all over the place with a live cable in it. So yeah, very close to the entry point to the house. Power comes out of that then down into your inverter. So the inverter there, in this case, it looks like about 5.5 kilowatt, but that's about, to put a size on it, about 2 foot by slightly less than 2 foot, so call it 24 inches or whatever that is, or 20 inches, sorry. And it's about maybe 8 inches deep. You have DC isolators, right? You have AC isolators, and then you have all the labeling and stuff. All of this labeling is mandatory, and quite often a lot of companies fail the SAI inspections for simple stuff such as that. You know, it's yeah, anyway, it's just pain in the butt, but it has to be there. So this is a case here then where we have batteries, right? So up maybe overhead here, we can see the DC cables are coming down into the inverters. You have the isolators here still. You have a double socket from the battery, which allows us to run, if you wanted, whatever extension leads or laptops or broadband or whatever it is from here. And then you have your battery. So you have 10.2 kilowatt hours here. So and you have all different types of batteries. Some of them are stackable. These ones are individual, either floor or wall mounted, as you can see. And that's taking up space. So in that case, it looks like it's in, I couldn't say actually whether that's a utility room or whether it's a garage. It looks like more like a garage, maybe. Not a beautiful photo, I'd have to say. So then I'm going to come back in a second to maybe more solar stuff, but I just wanted to make the point here, first of all, that sometimes we often do a presentation and it's, I suppose the title of it is solar is the right step, but is it the right first step? And sometimes when you take solar as the first step, it actually excludes you from being able to get other grants in the future. Okay, so we would always tell people when they ring us, we've no problem giving you solar. We would ask them to just be mindful, is it definitely the right thing to do? Because what we don't want is we don't want somebody coming back to us in a year's time saying, actually, I was entitled to window and door grants or heat pump grants or project management grants, but now that I've put in solar panels, that's no longer true and I'm not happy with Ashgrove. So we just make people aware of it. Whatever they do after that is up to themselves. So, but the range of grants that are available, as you can see here in the red X's, these are no longer available to you if your house goes above a certain BER. As of the last few weeks, that's no longer exactly true, but I suppose the principle is still correct. So we just have to be careful that if we're taking solar as a first step, that we know we could potentially be leaving, as you can see here, floor insulation. It would be unlikely to be putting floor insulation into a house maybe where they're currently putting in solar. But 3,500, you can't get that grant again. Rafter insulation, 3,000. Mechanical ventilation, 1,500. Air tightness, 1,000. And project management there for a detached house, €2,000. So we're just flagging it. There's an extra 11,000 there that you can get if you get into a one-stop shop or a CEG grant. Sometimes if you've done solar already, it might be a problem. We're just flagging that. So I'm going to skip through those onto this one. Sorry, the next one. So this is a one-stop shop case study. This is only to make the point again that I just spoke to you about. So these people contacted us, I'm going to say in 2000 and maybe 23, 22 maybe. These people contacted us. You can see relatively new houses. They were actually built in 2003, 103 square meters. So that's whatever, 1,100 square feet or thereabouts. C2 So already quite high on the BER ladder. They were looking actually to start off with, they were looking for the green mortgage. So a B3 would have done them. So they'd have easily gotten there with solar. But what we said to them was, if you take that first step and get the solar panels, they were removing themselves from the one-stop shop or the CEG grant, and they were going to leave money after them. So what we suggested to them was, while we're there with I'm going to say a project manager or whatever, an electrician maybe, and so on, that we could do more works. So what we suggested was attic and cavity, which were essentially free because the grant covered the cost of the works. To do the air-to-water heat pump, the grant for that today is 12,500, which means it's essentially a free heat pump or close enough to it, and put up the solar panels. At the time here, solar panels were about 7,000, but all of the work that you see in that list was done for 8,000. So what's after happening in the one-stop shop there, all of those additional grants, including the project management and so on, was available. And so solar alone was 7. Everything you see there is 8. It's a no-brainer. They should have gone the one-stop shop. They did go the one-stop shop, but sometimes we hear the one-stop shop getting bad press, and in the wrong place. If we use it, it definitely is a difficult grant to use, but in the right place, it's a fantastic grant mechanism, and it shouldn't be discounted. It gets a lot of stick. We're defending it more often than not. Not pushing it by any means, but we're just making the point that some places it is the right thing to do. So in this case, just to show you the full figures, the cost of the project was 25,000. There was 17,000 of grants available. So whatever it was, 2,000 or 2,100, maybe 2,400 at the time for solar. You got all of the heat pump grants, you got the radiator grants. If you needed to change the radiators, you got project management and the attic and the cavity. So the beauty of the one-stop shop here is that the customer actually only pays Ashgrove 4,000 day one with the order. And then we come out, we'd fit, say, the attic insulation and the cavity wall day one. We might do the heat pump day 2, the solar panels day 3, and we do all the wiring day 4. We're in theory finished all there in a week, maybe 2 weeks. And the customer at that point pays us the remainder of the 8,000 euro. And it's our problem then to go off to the government, to SCAI, and claim our 17,000. So that was the original premise of the one-stop shop, that it makes it extremely easy for the homeowner to find, in this case, 8,000 versus 25, and then all the hassle of the paperwork and dealing with SCAI and having to wait 2 weeks or 2 months for the grant. They made that the company's problem. That's so in this case, it's Ashgrove's problem to go off and look for the 17,000 euro from SCAI. So in this case, they went from a C2 to an A3. At a cost of 8,000 euro. Now keep in mind that was 2022, 2023, and it was in North Cork, not in South Dublin. So those prices need to be, there's a pinches, or there's a, what would you call it? Need to be taken into consideration. Apologies. Right. So tips and tricks. We would say here, number one, this is slightly outside of solar panels, I suppose. Check your electricity tariffs. Many people don't look at this, and they will not change from one end of the year to the next, or forget entirely. So we often see people leaving it go for years and years, but you know, it's the same as anything like insurance. If you leave it go and don't and don't change your tariff regularly, you're going to it's going to creep way up. So that's the first thing. The smart meter, use the ESB smart meter portal. When upgrading equipment, consider, you know, if you're changing a fridge or a freezer or your light bulbs or tumble dryer, obviously it goes without saying, take the opportunity to pay a bit extra maybe, and to get something a bit more efficient. And you know, anybody who goes to the trouble of installing solar panels, we always like to say to them, maybe buy a few of those little electricity meters. You plug them in, you plug your kettle into it, you plug your tumble dryer into it, and that, I suppose, their knowledge or understanding increases over time. And you know, in a lot of cases, a few months later, they come back saying, yeah, the solar is great, we didn't realize really what we were doing with the tumble dryer or whatever it is, air fryers or whatever, and that over time that their knowledge evolves and gets more efficient. Okay. So the start delays, obviously, on any of the dishwashers or washing machines or whatever. Some people ask us about leaving stuff on standby. And, you know, I suppose turning off televisions and stuff like that. It is good to do it, but the reality is it's minute, the amount of energy, of course, we're telling people to turn stuff off. But compared to using a tumble dryer or a heat pump or an electric shower or kettles, your television being on standby is all but irrelevant. Okay. Anyway, still good practice. Energy monitoring, we've already spoken about. So here's an example of solar panels on a garage. This looks, I always have to explain this one. These looks like power cables coming across from the garage. Obviously not, they're for hanging clothes. Yeah, so nothing really to show other than that. We show the brackets here and how it gets attached to the roof. I have more pictures in a second, but this rail that we look at here is where the solar panels are clipped onto. Today we use we've always used deionized aluminium, is it? Or anodized aluminium, apologies. And the panels are clipped onto that. So they're, I suppose, rust proof. And then the bracket where it's, I suppose, penetrating the roof needs major consideration. We know that in some cases what is used here is silicone. And fellows are drilling holes down through those slates, and silicone is expected to fix the problems. It won't, obviously. We all know what will happen to silicone in a year or 2 or 3 years' time. You're going to have water coming in through your roof. So I say if I was talking to anybody and I was giving them advice, this is where you'll separate the men from the boys, or the cowboys from the professionals at that particular part of the roof there. The AD diverter, not to be mixed up with an inverter. The AD diverter is a device where if I do have, if I do want my solar array to do hot water, the AD diverter is the little device which makes that happen. There's a little bit of tech inside in it. And if you have a heat pump, we would say you probably don't need it. It's more efficient to put that power into the heat pump. The heat pump is, I'm going to say, 350% efficient when it's in hot water mode. So I'd rather put the electricity into the heat pump and let the heat pump produce hot water. But if you don't have a heat pump, an AD diverter, especially if you have an oversized array, and if you don't have a battery, an AD diverter isn't a bad idea. I hope Mike is dealing with questions. Actually, Mike, if you want to come back into the room here, I know you went out to make sure the sound was okay, but I will keep going. So ground mounting is something, I suppose, that's becoming, I won't say more and more popular, but we're seeing more and more of it. The reason being, you can get more solar panels standing on a little frame like that than maybe you can on the roof of your house. If you have a relatively small roof, especially if you have little Velux windows, or you have a little hip coming out for whatever, you very quickly get restricted on what you can put on the roof. So you can see here again, they don't have to go onto a concrete slab like you see here. In very windy areas, we would suggest you do, to make sure that they don't get blown away. Sometimes you can use ground screws. I don't know if I have pictures of them here in this presentation, but certainly you want weight if you're in a windy area, albeit obviously that the solar panels are going to be facing south, so they'll be facing the prevailing wind. Obviously, if the wind was coming into the back of it, you'd have a bigger issue. Here's another one. So these are the all black panels in that case. They're in portrait. The other one was in landscape. Doesn't really matter. It might just be preference or height or whatever. nothing. So these are the ground screws. So rather than pouring a pile of concrete here, obviously there's a cost issue, there's a timing issue, there's a carbon issue when we look at, 20 cubic meters of concrete or 100 cubic meters of concrete or whatever it is. So what happens with these screws is, I don't know if I've got a picture of them. They're essentially a screw, but 100 times bigger than a standard screw. We use a thing like a drill with a very long arm on it to screw it down into the field. And then we essentially attach this bit onto the top of the screw here. And again, the frames just get attached in after that. So then, nothing to see here, I suppose. Standard arrays. I suppose the thing that we're always interested in is it slate or is it tile? With the slate, you can see here that we have to strip back a few of them. We have to notch then a slate. We have to screw on a little stainless steel bracket like this. We fix it on there. And then you put back in, you can see here, the fella on the right, this fella. And that stops any moisture going up here, even in strong wind, and getting in and causing trouble. Once you have that installed, you then fix the brackets we saw a while ago onto it. Once the brackets go on, you're then attaching the panel to it with these little clips. And these are obviously designed for Ireland and even the west of Ireland, which of course, where we experience high wind more so than the rest of Europe or many parts of the world. So that's that. Okay, fine dirty roof. But you can see all of the various things there, and the cabling is attached onto the brackets as we go, and then the panels sit on, etc. So I don't know, is there anything else in those that we want to see? I suppose we do, of course, as well, non-domestic. I don't know that there's anybody here this evening for non-domestic, but if you have any questions, we'll do up to kind of 300, 400, 500 kilowatt, I suppose, comfortably. So, Mike, have we any questions we want to deal with?
Just about charging the batteries at night.
Okay.
Is it a good idea or not?
Okay. So I'll just read it out. Is that the one there? As part of an upgrade, should I consider moving to a day-night meter as well as battery? It could be charged at night during the winter when PV performance is lower. So that's quite a common one there. I can't see a name. So we can, you could actually do that whether you had solar or not. So you can imagine I've no solar and I just have a battery. There is in some cases a kind of a business case, we'll say, or to just take cheap or in some cases free electricity by night, put it into the battery, and then I use it by day. We always, when we look at that, it might seem to be a kind of a no-brainer, but in some cases, when you buy a battery, they have kind of a lifespan. Every time you fill it and discharge it, you're using one of those discharges. The various batteries will have 8,000 discharges or cycles, 10,000 cycles, and so on. So every time you're using it, you better make sure that you're saving money, because you might think you're doing the right thing, but in 5 years' time, you've used your battery and it's done, and it mightn't be the right thing to do. So, but certainly once you understand the maths there and do the maths out, you'll get to the bottom of it. If you want us to give you a hand with that calculation, by all means. We actually do another kind of a follow on from this seminar or webinar, getting the most out of your solar. So it's for the people who've actually done it and they're out the far side of it, and we probably go into that calculation a little bit more there. Maybe we should probably put it in here as well, but you can't cover everything. What is the max distance between garage or the ground mounted panels and the house? Is there an ideal maximum? There is no maximum actually, Helen, but it's like anything. The further away you go, it's like having pipes or anything. The further you go, the bigger it needs to get, because you have a volt drop, and to deal with that, the cable gets bigger, which means it gets more expensive. Of course, you also have more of it, and so it ends up becoming more and more expensive the further you go. But we often see, Helen, in domestic cases, maybe up to 20 meters isn't prohibitive. But like if you're talking about 100 meters or whatever, we're starting to ask questions, certainly. But there's no definite right or wrong answer there. So Kieran, If using solar for car charging during the day, is an eddy diverter needed? So the question there, Kieran, is I would only put in the eddy in that case if I had surplus electricity. So if my house was using, say I was producing 6 kilowatts, my house is using 1 or 2, my car is there, and if the car never gets full from the solar, I'm not going to have spare electricity to put into the eddy. Yeah, is that all of the answer? Depending on now whether there's a heat pump involved or not, Kieran, maybe I might change my thinking there. But yeah, I suppose that's the answer for now. Let me know if there's a heat pump. Oh yeah, sorry, Helen came back with a follow-on question. This is to do with the distance between the ground or the garage and the house. Yeah, thanks. But does the electricity generated actually fall as it passes through the wires? Yes is the answer, Helen, and that's why we make the wire bigger. The bigger the wire is, the less the voltage drop. But it definitely does. We just make the cable bigger until it essentially becomes negligible, but that comes at a financial cost day one. So we try and, yeah, 20 meters, call it, Helen. Any more than that, we can calculate for you. How close should the battery be to the inverter? I would say it's always essentially beside it. I have no name there, it's anonymous. But now sometimes you might have the battery outside. We see that more and more where people don't have space for them inside, so they might be mounted to the outside wall. Obviously, they're IP65 and they're rated per water and moisture and all the rest of it. But they're typically beside Mike. Am I wrong there?
The new ones are IP66.
Yeah, IP66, yeah. But in terms of the inverters being beside the batteries, are they always beside?
Always, yeah.
Yeah. So that's that. So Kieran has no heat pump or hot water tank using a gas condenser boiler. Yeah, so the AD in that case, Kieran, if you have a condensing boiler and you don't have water storage, the AD isn't going to work for you. The AD is a little bit like the solar panels. It's like dumping energy into a battery. The battery in this case would be in the shape of a water tank. But if you take out the water tank out of that, you don't have a volume to dump the energy into it. So I definitely, in your case, would not use an eddy. Any other questions there? So we're coming up to 5. I'll keep answering questions, guys. If anybody wants to keep going, I'll keep an eye on it. I'm just going to skip forward to tell you of upcoming events. I see 1 or 2 other questions coming in there. I'll answer them in a second. On the 10th of April, I don't know why it's at the bottom of the page, we have heat pump common mistakes. That's a very popular webinar. We suspect, or my view here is that 70%, 80% of the heat pumps we see in the country today are badly installed or commissioned or operated. And so we try to, again, a little bit like the solar, how to get most out of it. We want to, I suppose, show people, number one, ideally don't make these common mistakes when you're putting in a heat pump. But if you have, what can you do then? We have, on the 20th, we have Understanding Solar Commercial, Vacant and Derelict grants we're doing a lot of, 24th of February and the 13th of March. We have deep calculations for one-stop shop, 27th of February. That's a very technical talk aimed at architects, engineers, BER assessors. Windows and door grants upgrade since the news on the 27th. The window and door grants now is available as a standalone grant for a house. A lot of people are delighted by that, but they don't understand there are a few criteria. We've just released a video on YouTube explaining the walls have to be at, I think it's 0.39 or 0.46 in order to get the window grant. The attic has to be at 0.31, or the overall heat loss indicator for the house has to be better than 2.3. Some people have simplistically thought that it was, there's window and door grant there and I can get it, but it's not as simple as that. We explained that in another webinar. 10th of March, solar domestic again. Advanced heat pump installations on the 13th of March. Mullingar Park, vacant and derelict, so that's a 2-hour talk. And then business energy upgrade. So that would be for somebody either doing up an office or a factory or something like that. They're entitled to up to 30% grants. And depending on what type of grant mechanism you go for, or if you're changing a motor or boiler or whatever, there's probably 5 or 6 different grant mechanisms you can look at. And we go through all of that on the 20th of March. So contact us or go on to the bottom of our webpage ashgrove.ie. Okay, I'll go back to the questions. So, Kieran, thank you. Sean, can the recording be made available? Yeah, it is, Sean. Yeah, we'll send that on to you after. No problem for joining late. That's the way it works. Do you record these webinars? We do, yeah. So, yeah, watch them in one go. Yeah, no bother at all. Yeah, if for any reason we're absolutely inundated at the moment, guys, we're, things are gone absolutely crazy since probably September, October. So if we're a little bit behind and any of you wants the recording and we haven't gotten around to sending it out, we're typically a day behind. So this will be sent tomorrow. At the moment, it's probably 2 or 3 days. So if you want to reach out to the office and contact us, be sure to do it. And there's no problem with that. So that, other than that, I'm done here. Myself and Mike are done. We've gotten successfully through that. Mike Dennehy is standing beside me, so many of you will probably be potentially already dealing with him. And we've done everything else, Mike?
Yeah, all good. We've covered everything.
Yeah, I think, Noel, we've answered your question there. Why would you be careful about doing solar first? You just end up, just to reiterate, you've taken the house so far up the BER ladder that that the one-stop shop grants aren't available to you any longer. Okay, so you can't get project management, you can't get the floor insulation, that mightn't matter to you. So the project management is €2,000. Floor insulation is 3,500, ventilation 1,500, air tightness isn't available to you, and so on. So you're leaving a minimum of 11,350 or whatever we said earlier by shoving your new starting point up to whatever it is. It was worse in the past, by the way, because the heat pump grant was 6,500 through the Better Energy Homes grant, whereas the one-stop shop was 10,500, but that's after being rectified, and the windows and doors similarly. Any other questions after coming through late there? Yeah, sorry, the B2 actually is removed as a starting point. Thomas, that's correct. Yeah. So that's for the starting point for a one-stop shop. Yeah, and the 100 kilowatt hours is removed as well, Thomas. The 100 kilowatt hour minimum improvement is removed, provided you have a heat pump. It's expected that if you do have a heat pump, that it's a given that you're going to reach the 100 kilowatt hour improvement. Yeah, and are the recordings on YouTube, or where would I find the historic ones? Yeah, you'll find some of them on YouTube. I'd say I'll go as far as to say you'll find all of them on YouTube. There's a health warning now on the 27th of last month, anonymous, whoever you are. Some of the rules have changed, and so some of the earlier, we'll say even going back 6 weeks, they might no longer be correct. So just be careful. Yeah, thanks guys for the kind words. We're finishing up at, believe it or not, exactly 6 o'clock. Have a nice evening. Thank you for joining us. Be sure to reach out to us. If people are looking for CPD points, yeah, no bother at all, guys. We look after that in the next few days. Okay, have a nice evening. Take care. Thanks for joining. Thanks, Mike.